Good afternoon. My name is Sonora Monks, ESA's Director of Programs and Education. Thank you for attending today's webinar titled NFPA Standard 855 and the International Fire Code. Today's webinar is being recorded and will be made available at www.energystorage.org. Participant lines will be muted throughout the webinar. However, we welcome your questions and comments, which can be submitted at any time via the chat box on the left side of your screen. Following the webinar, you will receive a link to the recording and slides, as well as a brief survey regarding today's topics and topics for future webinars. Your feedback will ensure that ESA continues to provide the highest value information to you and your company. Today's speakers are Steve Cummings, who's Director of the Sensor Division with Nexceris, LLC. We also welcome Laurie Florence, who's Principal Engineer with UL, LLC, and Chuck Foster, who's Technical Consultant for the Energy Storage Association. Before we begin today's presentation, I'd like to invite you all to submit a proposal to speak at the Energy Storage Studio Conference. Produced in collaboration with the Electric Power Research Institute, the Studio Conference is designed to examine the steps necessary to successfully integrate an energy storage product and evaluate the ways companies are deploying storage to lower costs, reduce emissions, and establish a more resilient grid. The conference will be held in Charlotte, North Carolina on October 16th and 17th. For more information, please visit www.energystorage.org/storage-studio. ESA works to accelerate markets, connect members, and educate all stakeholders. Our members directly influence our educational programming. If you'd like to learn more about membership value-add opportunities, please feel free to contact our membership manager, Richie O'Neill. Thank you for your time today, and without further ado, I'll turn it over to Chuck Foster to begin today's presentation. Chuck? Chuck, is your line muted?
Let me see if I can start over again.
Thank you, Chuck.
Good afternoon to all. Just for the record, we were given explicit instructions. Do not mute your line, and if you do, unmute before you talk. So I'm already off to a great start here. Today's webinar is about standard NFPA Standard 855 and the International Code Council's document, the International Fire Code. And as a little bit of background, I think it's worth spending a moment trying to understand what's the difference between a code and a standard. And to help with that, because Standard 855 is a standard and the International Fire Code is, of course, a code. So the NFPA says that one way of looking at the differences between codes and standards is that a code tells you what you need to do, and standards tell you how to do it. The practical difference, and over the years, one distinguishing feature has been that codes will talk in enforcement language, mandatory language, and standards will talk about specifications. That distinction has been blurred as of recently. Most standards talk in mandatory language and code enforceable language, but I think the takeaway is not to become an expert on the differences there, but to understand that there is a difference. Clearly, codes and standards can have a huge impact on an industry's ability to market products, and that is, of course, what's driven the recent interest in NFPA's 855 and the IFC. There, just as additional background, there are antitrust implications of codes and standards activities. That is that occasionally the FTC or others will notice that someone is trying to gain market share through the prescription of a detail that's exclusive or can only be supplied by one company. So I think that with that as a background, let's look at Standard 855 versus the IFC. For the scopes are essentially the same. We're going to deal with these in more detail in just a few minutes, so I'm not going to dig in too deeply, but the scopes are essentially the same. The purpose is a little bit different, as we will discuss. And so moving to adoptions, it kind of begs the question, what happens when you do have a standard 855? How does that impact the market? Same with IFC. Well, they're not self-enforcing. They have to be contained in either a state law, federal law, or regulations before they will have a market impact. And so the IFC has been adopted by 42 states in the District of Columbia. That means that on a regular basis, if you're going to install a energy storage system in one of those 42 states, you have to comply with the requisites of the IFC. And if I just left it there, it might leave the impression that there's not too much to think about with 855 if 42 states are using the IFC, but it's misleading. There's a great deal of overlap there, because while Standard 855 has been adopted by as a standard, it's been adopted by 0 states, no jurisdictions that I know of. Standard 855 is referenced in NFPA 1 and NFPA Std, of course, the National Electrical Code. So by reference, it's also applicable. It's a lawyer's dream to try to figure these things out, but the another difference between Standard 855 and the IFC is how they are developed and promulgated. And both of them use what they call a consensus process, consensus meaning that it has to be more than a simple majority but less than unanimity. And both of them, in order to comply with ANSI requisites, have to exercise due process, which the cornerstones of it are notice and the opportunity to be heard. All right, I think I've probably worn you all out on the background there. So who is engaged in these things? The public. Of course, manufacturers have an interest. They'd like to know that the product they're building will be can be sold into the marketplace. Installers, NGOs, SCOs, standards development organizations, trade associations, academia, government, any of you that have gone or participated in the development of a code of standards know that it's a broad cross-section of people that are involved. And on that note, I think about the development of codes and standards as a ship noticing an iceberg. What they see, most consumers see the top of the exposed part of the iceberg. They say, yeah, I understand UL makes a standard, the National Electrical Code, but they don't understand that it has all these public inputs, a broad cross-section and the input from many, many perspectives. And so focusing now on Standard 855, there's an existing Standard 855. If you go to the NFPA website, you can see that the existing process was started to revise the standard in 2016. And the first draft report was published here just a little more than a month and a half ago. Currently, they are accepting comments on the first draft report through July 12, and notably, these must be submitted electronically through the NFPA portal. For anybody that hasn't looked at it, it's pretty straightforward. You can just go to the NFPA 855 website, webpage, and there will be an icon to click on it. At this point, NFPA expects to finish publication, actually publish it in 2019. It's worth noting that when they began this exercise, the target date was July 2018, so right now, so I won't say they're behind. I think that the original schedule was just overly aggressive, and they weren't able to keep up with it. So what's the scope of Standard 855? Ostensibly, it's stationary energy storage systems that are larger than 70 kilowatt hours for lead acid and NiCad, and 20 kilowatt hours for others, for lithium-ion, sodium, 10 for others. The purpose is to minimize hazards, and I've lifted that language straight from the standards. And might ask, what is driving this interest in minimizing hazards, or for the development of energy storage codes and standards generally? And there have been a couple of notable fires. One, and there's a very interesting article for anybody who wants to Google it, in Scientific American, about a wind farm in Hawaii that had a number of fires, and the firefighters were concerned, could they go into the space and try to extinguish the fire? It was in a warehouse. Would they be electrocuted if they sprayed water on it? They tried using carbon dioxide, it wouldn't put out, and it burnt for several days. And there are several other examples of it. But what's the purpose? It's to minimize hazards for firefighters and for people. It's generally not so much for property protection, as the instructions are generally just to let it burn, but it's firefighters are the primary driver. And if you look at the composition of the Standard 855 committee, there are a number of fire professionals on there, fire marshals, etc. Generally not retroactive. At least the current provisions say it's generally not retroactive. Of course, a code official, if they find something to be, in their opinion, unsafe, they can apply anything retroactively, but generally the provisions are not to allow retroactivity. Definitions: one or more devices assembled together capable of storing energy in order to supply electrical energy at a future time. That's the exact same language that you'll find in the International Fire Code proposal. And that's not surprising that they're exactly the same, because there's so much overlap in the membership. People that are working on the IFC are also working on Standard 855, and so they've borrowed language. There are also definitions for cabinets, walk-in units, dedicated use building. The word container is used in the standard, but it's not defined. Just out of curiosity, NFPA 855 requires permits, plans and specifications, operator O&M manuals, a commissioning plan, training, and we're going to hear more about some of these items from Steve later on, but hazard mitigation analysis, if required, would include thermal runaway and control failures. The issue of permits, let's talk about that for just a bit more. the permits that are required under 855 have less definition about them than we find over in the IFC. The IFC explicitly references building plans and specifications and the permits. 855 just kind of generally says permits are required if required. I don't think that's going to make any substantive difference, but it's a nuance that we probably ought to take a look at. Training, there's 2 or 3 typos in here. I'm going to point out one of them right now. Refresher training, at least yearly, that was struck. So there is training required, but there's not an annual update on the commissioning training. Move over to large-scale fire test, and Laurie is going to talk, I think, in-depthly about this in her session. But UL 9540A is a method of test, and large-scale fire tests are required to, if in several locations in the standard, if you would like to be excused from the minimum or maximum requisites of various provisions. Equipment has to be listed in accordance with 9540, with UL 9540. There are signage requirements, meaning you have to identify the type of batteries that are there, emergency phone numbers, etc. Generally, for construction, fire areas require 2-hour firewalls. There can be additional requirements if this is inside of depending on the type of building that they're located in. And so for indoor installations, the standard 855 breaks it down into dedicated use buildings versus non-dedicated use buildings. Again, those terms are defined, but you don't have to look it up. Your intuition will probably drive you to the right answer. Dedicated use building is simply a building that has nothing but the ESS equipment in it and its associated electrical, maybe switchgear, that kind of thing. Non-dedicated use would be general commercial occupancy that had an area set aside for the ESS systems. So we looked at indoor just then. Outdoor installations can be broken down into remote and locations near exposures, where again, those will provide needed exceptions for people who would like to exceed the minimum or maximum requisites of the standard. So the max size here for an outdoor container would be 53 by 8 by 9.5. And I had someone call me yesterday, say, where did those numbers come from? Well, they were admittedly somewhat arbitrary, but that's the largest standard ISO size shipping container that the code officials had seen. So I think that number is malleable. If people are building products that are larger than that, I would suggest that they file comments, and I don't think they would have a whole lot of opposition to that. So size and separation, this is getting into kind of the meat of the standard. This is 250 kilowatt hours maximum size of groups under NFPA. as you'll see here in a few minutes, the IFC is different. The IFC is 50 kilowatt hours. So that's a pretty substantial difference in the two. 3 feet minimum spacing between groups, and that's the same for both. There are exceptions available. 600 kilowatt hours maximum rated energy for areas. And so if you wanted to put in more than 600 kilowatt hour storage inside of a building, you could do it. That doesn't mean you can't put more than that in a building, but you'd have to divide it into several spaces. Again, there are exceptions. I'm going to, looks like I'm slow, moving along a little more slowly than I had thought, but so I'm going to move through these pretty quickly. The various detection and fire suppression provisions, there are smoke and sprinkler. Again, Stephen is going to talk about these more directly. There are other chapters on interconnection, commissioning, decommissioning, and I would commend to everyone's attention that's interested in NFPA to take the time to go through Appendix A, the explanatory material. Appendix A helps to give the background as to why certain decisions were made. And again, I would commend to your attention. Okay, the IFC, International Fire Code, the process is different. I'll start with the International Fire Code, again, has 42 states in the District of Columbia that have adopted it. But it's not technically an ANSI standard. Well, it's not an ANSI standard. They hold themselves out to be a consensus process, but it's not an ANSI standard. The IFC was last published in 2016. The next publication will be next year, and they are currently accepting public comments through July 16. Just like the NFPA, the comments must be submitted electronically through the ICC's web portal. Okay, the scopes are very similar with 855, lead acid more than 70 kilowatt hours. You can read the other couple of them. The purpose, so there's a question mark there. The IFC doesn't state an explicit purpose, but it's the International Fire Code, which is essentially owned by the fire marshal. So I think that it's fair to say that the standard of the purpose is to mitigate hazards associated with ESS, just like Standard 855 is. Again, it's generally not retroactive. One pretty big difference is that the IFC has a utility exclusion in its scoping statement. It says that ESS installations that are under the exclusive control of utilities or their agents are excluded from the requisites of the standard of the code. And that's pretty significant for anybody that's doing grid scale ESS. I should point out that that both the Standard 855 and the International Fire Code also have a number of exclusions for telecommunications utilities, and which seems appropriate under the various defined circumstances. In the NFPA, to be excluded from applicability for the telecommunications utilities, you have to also comply with NFPA 76. So the definition is the same. They also have definitions for a cabinet, a walk-in unit, a dedicated use building, and they provide a little bit more background on what a container is, and again, referencing the ISO sizing. Permits are required under the IFC. Again, plans and specifications, O&M manual, training. Under the IFC, though, training has to be provided, refresher training has to be provided to the operating staff at least yearly, which different people may have different views on it. That seems a little onerous to me, but again, hazardous mitigation analysis, some of these things will be dealt with more in Stephen's presentation. I think we've covered those under 855. The maximum rated energy, just like in 855, 600 kilowatt hours generally. And there's an appendix that I would ask. So that's my handoff to Laurie.
Okay, well, thank you, Chuck. And I'm going to be moving on to UL standards that are referenced in the codes that Chuck was just talking about, UL 9540 and several others. And these are just some updates. So just an overview of UL 9540, of course. It's an ANSI Canadian standard, national standard for both the US and Canada. Energy storage systems and equipment is the title, and it's a safety standard. And it's for energy storage systems that can be connected as like a standalone system, or it could be connected in parallel with a utility, or it could be both. They call it multi-mode, I guess. There was a question I noticed off the side. I was sort of reading the questions. What if it's a UPS? Well, UPS, if it's strictly a UPS, it's UL 1778. But an energy storage system could serve that purpose, but not if that's all it was doing, it would be under UL 1778. So it could provide some backup power, but that should not be the only thing it does because it operates during normal operating times too. And it's not just a battery system. It could include, which is the electrochemical type systems, but we also cover mechanical, chemical, and thermal ESS. So not just battery, although primarily what we see is battery. And I apologize if this looks a little bit like an eye chart, but UL 9540 is set up pretty much like many UL safety standards. We have construction requirements, and one of our important ones is that we require a safety analysis such as an FMEA of the system, any kind of electronics or software. If they're deemed critical for safety, need to go through a functional safety investigation to appropriate standards. We have material requirements and closure requirements, including for walk-in enclosures, because these could be very large systems built into containers that say someone may walk in temporarily to do some servicing and stuff. So we have to consider, they're not completely a building, but there's things that have to be considered for the safety of workers dealing with them, as well as any kind of parts containing hazardous fluids or under pressure. We address fire detection and suppression in the standard, and we have technology-specific criteria. And by technology, I would say, for instance, the battery systems of a UL 9540 product would have to comply with UL 1973, which I will also be talking about there. Things like mechanical systems such as flywheel systems, we do have a specific set of tests in the standard that cover those. And we make reference to a number of standards for existing technologies that we can refer to. It's not our intention to reinvent the wheel if there's a standard out there that it deals with a specific type of energy storage technology. Testing criteria, we have them broken up into a number of tests. Actually, most of the testing for energy storage systems are covered by the critical component standards, such as UL 1973 or UL 1741 for the power conditioning system, for instance. But we do have a set of tests to look at the overall assembly, including electrical tests such as, kind of an operating temperature test to make sure everything, when it's operating under load and maximum loading conditions, that everything is within the temperature range and operating as it should be. We have a number of insulation tests such as dielectric and insulation resistance. We have a surge test, impulse test, check of the grounding system, et cetera, things like that we do as part of the electrical tests. Mechanical tests, again, as I had said, we cover flywheel systems stuff. So there's a number of different tests to evaluate the robustness of the flywheel containment system and its construction, as well as pressure and leakage for fluid containing requirements. And then environmental tests, whatever the rating is, if it's going outdoors, if they need to be evaluated for exposure to rain or seismic, installations and stuff like that, if there's a rating for that, we'd have to look to see that it's been evaluated for the appropriate seismic zone and salt fog and things like that. So that's covered under environmental tests. And finally, production tests. This is, if they're making multiple samples, of course, the production has to be checked before it goes out the door, and this includes, sort of high pot testing and ground check testing and a check of the controls to make sure they're functioning before the thing goes out the door, just kind of what you would expect in a safety standard. We also have marking and labeling, quite an extensive nameplate requirements for these devices, for the inputs and outputs, et cetera. Cautionary markings, including arc flash warnings, and shock hazard, restricted access, et cetera. So a number of different markings and labelings, as well as making mention of any labelings that are required per the codes. They're working on a label in NFPA 55. Some of these battery systems have toxic stuff, so there's a number of different labels that may be required. So you have to look at what's in the codes required. And we have instructions to installation, maintenance, and operation. So we cover all of those things in 9540, just as we would with any kind of safety standard. So just a little quick overview, because I don't have like 10 minutes to speak here, covering quite a bit. But we were published, oops, and I have the wrong number there. I'll have to correct that for the record there. November 21st, that's back in 2016. Somehow I was thinking 2016 and typed 2018, so I apologize for that. So the first one should be November 21st, 2016. The second one, in the third quarter of 2017, we opened it up and asked for a request for proposals for the second edition, and we did receive quite a few proposals. I talked with our standards. That should be coming out, a bulletin of the second edition for review, preliminary review before going into voting should be coming out this summer. I think part of it is my fault. I've kind of inundated my standards person. We were on continuous standards revision at UL. It means you can send a proposal anytime for consideration. And I've basically loaded up every one of my battery standards that are going under some type of revision. So it could be my fault that this hasn't gotten out sooner, but she promised me this summer we'll see this bulletin. So moving on to 1973, and this is a very important one. This is the battery system standard, and it's referenced in 9540. It's required for 9540 battery energy storage systems. We changed the title. We have a second edition that came out February 7th, 2018, and we changed it to make it more represent what we actually typically cover under the standard, and that's stationary. We've added vehicle auxiliary power because that industry was very interested in using 1973. It's essentially does, it would be something that isn't the traction power in a vehicle, but something like for instance, an RV, whatever's powering, say, your appliances and stuff in your RV, that auxiliary power system. So we're including them as well. The change, we included some arc flash stuff. We should have probably had that from the beginning because it could very well apply to these battery systems, so we've added arc flash markings and instructions. We have a short circuit current rating that was important to the inverter industry. I mean, anyone's connecting to a battery system wants to know what that short circuit current is so they can, see if their system can handle that. So we always do a short circuit test. We've always thought in terms of, how is the battery protected, but at least this way when we do the short circuit test, we're looking at what sort of current and the time coming out, and we're requiring a marking so that whoever's connecting to that battery knows what to expect if there was a short circuit. And then we did some revisions to what we call the internal fire test. And that's a very important test in UL. It's a propagation type of test. We changed the name. Now it's got a very long name now, to more represent what it means. It's a single cell failure design tolerance test. We have two methods, one for lithium ion and one for some other technology, sodium beta being the hot temperature sodium batteries, or lithium metal, or even lead acid. And we have some additional, an additional informative Appendix F that provides methods that can be used to conduct the cell failure. And some future considerations for 1973. I mean, even though we just published the second edition, we're looking at another group of changes to the standard. You know, kind of revising our cell criteria, providing some clarification for the vehicle auxiliary power. We're considering an optional to do as an option the 9540A cell testing portion. I'll talk about that in a few minutes, but to maybe do that under 1973, it wouldn't be required, but as an option. And then some revisions to external fire tests based on our fire research group. We have to change the nozzle and that and some other things we'll be doing to that external fire. Just to name a few things we have under consideration for that. So moving on, 9540A, that was mentioned also in Chuck's presentation. This is that test method that we developed to address the exceptions in the fire code and also in NFPA 855. And this is a test method. It was published almost a year ago. The first one came out. We're now on the third edition because we've had a lot of learning conducting this testing and have made some changes to it. And as I said, it's developed to determine those, whether it can meet those exceptions in the code. And of course, even though it meets 9540A, it would still have to be approved by the AHJ. And all of those exceptions, they say, large-scale fault and fire testing and approval of the AHJ. So there still is that needed. And we're going to be referencing it in 9540. As I said, it's a multi-step method. You do cell testing, which we may try to pull into 1973 to try to cover it there to help out with that portion of it as kind of an option in 1973. Then it goes on to the module, and both of those parts are information gathering. And then the final testing is the unit, and if necessary, the installation. And the unit is where you repeat the module test in a complete unit, surrounded by target units and installed as intended in the final installation. If there's problems with that as far as fire getting out, etc., then the installation is you repeat the unit level testing with the sprinkler or whatever fire suppression system you have in place operating at that time. So it's a multi-step testing, and it's quite extensive. So this is just kind of an overview of that, the timing. We published the first one back in 2017. Second edition of the test was January 31st, 2018. We recently published the third edition, June 15th, 2018. And we're going to begin the consensus process. So we're going to take that third edition and put a bulletin together for the STP, the 9540 STP, to provide feedback and turn it into a consensus document. We talked about putting in an appendix in 9540. I think it might be cleaner. We may just end up leaving it as a separate document. So that's the plan so far. And then finally, and one last standard that might be of interest is 1974, and this is a repurposing process standard. It's called Evaluation for Repurposing Batteries. It covers the sorting and grading process of battery packs, modules, and cells, and electrochemical capacitors, originally configured and used for other purposes, primarily electric vehicle propulsion. That's where that's where the interest of this is to use vehicle batteries in some other application. So actually, move on to this here. It's a process standard. It's not a product standard. Once it goes through, the manufacturer has been approved for this process, then if they want to build something for stationary application, then they would take these repurposed modules or cells or batteries, and they would have to go through the 1973 evaluation for that. So I just wanted a couple things because some of the comments that we have on it when it went through the review process was some confusion regarding repurposed versus remanufactured. And UL's always had like a remanufactured program for different products that are UL certified. And basically the remanufactured is where the original manufacturer may want to replace some parts. They get back a used product, they replace some parts, check it and test it, and resell it again as the same thing, just it's been sort of rebuilt or remanufactured, as we call it, or refurbished. And then we have a program where they can do that and market refurbished. The repurposed, which is 1974, is they take something and use it for another purpose. So this is primarily, I would say, electric vehicle battery packs would be disassembled and checked and tested and evaluated for their usability and then put together for some other package. So it's repurposed for another application such as stationery. And that's where the whole thing was kind of how they plan to do that. So the data on the 1974 is we had the bulletin out for preliminary review last year. We had a ballot out, and third quarter it did reach consensus. So we have a lot of comments. We're going to have to go into recirculation, as we call it, which means I'll be making changes to the standard, and it will be going out for review, those particular changes. But we did achieve consensus, and that'll be happening very soon. I've got the comments. I have to answer all the comments and make the changes necessary, and then we're hoping that this will be all done by the fourth quarter, and we'll have a published consensus standard for UL 1974. So it's moving along, but as I said, rather busy. So with that, I guess that's the last of my updates for the UL standards, and I'll turn this over to Steve.
All right. Thank you, Laurie. I appreciate it. My name is Steve Cummings with Nexceris. I'm going to talk a little bit today, and some of this stuff I'll try and get through quickly on the front end, but I want to talk a little bit about some of the fault detection requirements that are in NFPA 855 standard currently. And we're going to talk, because the NFPA 855 standard is an installation level standard, we're going to talk about the detection of faults that are external to the electrical interrogation of cells. So specifically what's required within that standard is detection for smoke and fire detection that's currently found in Chapter 4, Section 10. Some of these chapter references will be subject to change as it goes through public review or public comment. There's also gas detection and deflagration venting currently required in Chapter 4, Section 12. We'll talk also about some off-gas detection, which is not currently explicitly required within the standard, but can find place in, as Chuck was referencing earlier, the hazard mitigation analysis that is required within the standard. Chuck talked a little bit about the categorization of the installation types. He talked about the indoor, the outdoor. Those references are found there. And there's also installation types for open systems. Those would include rooftop and open parking garages. And then they have a separate installation type for mobile that includes any charging and storage of those systems prior to deployment. This next slide we'll take a look at here is a little bit like eating dry toast, so I'm not gonna go over it much, but it's really here for reference. And what we're looking at here are some of the specific references and exceptions that are in the current version of the standard for things like the smoke and fire detection as they pertain to both indoor, outdoor, the open installations and mobile. And then in Chapter 4.12, there is the requirement for certain systems, as noted there in the notes column, for deflagration venting to get rid of the hazardous exhaust that come out of the cells when they go under failure condition. So the idea there is to use a gas detection system to keep the overall environment below 25% of the lower flammability limit, again for the purpose of preventing deflagration. What we'll transition to talking to a little bit now is about off-gas monitoring of lithium-ion battery systems. And we'll start here in NFPA 855 in Section 415 is the section which currently requires the large-scale fire testing in accordance with the UL 9540A standard, as Chuck and Laurie have already kind of talked about. And that standard or test method, I should say, goes through a series of tests where they do evaluation of cell failure at the cell level, the module level, and so on. One of the areas to take a look at is within the cell level performance test. There are two specific and discrete data sets that are collected. What they're doing is looking at the temperature of the cell at the surface of the cell. Under a cell abuse test, they're looking at the temperature of the cell when the cell vents, and there's a specific definition there of venting, and then also the temperature of the cell when that cell goes into thermal runaway. And so when we look at those two discrete events, there's a point in time when the cell vent opens, and then there's a point in time in which it goes into thermal runaway. And the differential between those two events creates an opportunity for fault detection that is kind of a unique way of looking at fault detection. That brings us on to this slide talking about the stages of a battery failure. These stages is pretty much the most concise way of looking at a battery failure. And this work comes out of 8 years of battery failure testing that both we have conducted and surveys of battery failure tests throughout industry, including work that we've done with the U.S. Navy as well as ARPA-E. But if you start at the 12 o'clock position on this chart, it starts with battery abuse. And so this can be anything including electrical abuse, mechanical abuse, and physical abuse of the battery, thermal abuse of the battery. This is going to result in some kind of cell damage, which once you get to the 3 o'clock position there, you get to a point when those cells will vent and there's an off-gas release. If that cell continues to go towards failure, you're going to get a heat release that then is associated with smoke and fire, and that's where we see the point of recording in the UL 9540A standard where the surface temperature at thermal runaway is recorded. So what this leaves us with is there's two regions that we look at. One is a preventative region. Those preventative region is where we want to put most of our controls and fault detection into, because these are areas where we can still prevent a cell from going into thermal runaway. On the containment region is where we see most of our smoke and fire detection as well as fire suppression. And those are points where we're keeping that cell, or we're trying to prevent that cell from causing other cells to go into failure. So if we were to populate this chart with some of the typical fault detection as well as suppression methods and control methods that are used within industry, you see you start at the top, and it always starts with cell quality. So quality cells kept under control within manufacturer spec is really where the primary control within the battery system is going to come from. As you go around the wheel, you see as you get into the containment side on smoke and fire detection, this is where most of the fault detection that's specified within current standards come in. You have smoke detection through fire suppression, and then as you continue along the chart there, you get into what is really the non-propagation design. And what you're trying to do is prevent a failed cell from failing adjacent cells within the system and leading to propagation. But what happens is there's a region that's there around off-gas monitoring that's currently really not utilized. And this is what we've been looking at within industry to provide additional ways of providing fault detection on these battery systems, where what we're looking at is off-gas detection that should be included if the UL 9540A test report indicates that a cell vents prior to thermal runaway. So if that opportunity is there, then there's a means for looking at detection of that fault. And what I'm going to do now is walk through a case study that we did with DNVGL, where we looked at the failure of a cell. And we're going to walk through those various stages of the battery failure and kind of show you where these detection techniques can provide fault detection to improve monitoring of these systems. So this was a cell level test that was conducted. It was overcharged at 50 amps. During the overcharge test, an FTIR system was used to gather information on the species of gas that are evolved at different points within the failure of that cell. So the 2 points that are important here is just before 4,000 seconds, you see where the cell vents. At this point, you start to get a low level of gas that comes out. But what's important here is there's about 6 minutes that's prior to the thermal runaway event where you see those particular gases that we're looking at spike up to a much higher level. And what those are those two unique stages where you have a venting that's then followed by some period of time and a final thermal runaway event. If you overlay on some of the other gases, I won't go into detail on those, but the final overlay here is what can be accomplished with off-gas detection. And this technology that we work on, which is called Lion Tamer, was able to provide 6.5 minutes of early warning prior to thermal runaway. So it gives you an improved situational awareness of a fault that is beginning to occur within your battery system and provide some time prior to that. So the next question we really want to answer is that 6.5 minutes enough time to do anything valuable with? And that's what the next part of the case study looked at. So again, the same cell was taken up to the same conditions, overcharged at 50 amps. This time when the off gas was first detected, and you'll see on this chart, you see the FTIR signals again beginning to come up, indicating that that vent opens up. When we detected that gas with the Lion Tamer gas detection system, we stopped the charging of that cell. So we isolated it from charge and load. And what was able to be demonstrated on here, if you look at the cell vent, the surface temperature when the cell vent was about 50 degrees Celsius. And then sometime down the road, that cell continued to cool off, and that surface temperature never indicated that the cell went into thermal runaway. Kind of the purpose here is to demonstrate some of the new techniques that are coming down the road for fault detection within the battery systems that can supplement and really provide some earlier warning prior to the reliance upon smoke and fire detection alone, which is again in that the containment region that we looked at on the battery failure chart. So in summary, and I'll try and wrap up here and leave some time for questions, we looked at some of the sections where the fault detection currently is. We've also looked at some areas where fault detection can go using the measurement of the cell venting, looking through the case studies of those, and then demonstration that mitigating actions taken when a cell vents actually does provide enough time to help protect against thermal runaway. Which is one of the ways, if we dial back to the initial comments, that you can use this as part of the hazard mitigation analysis that is required within the current 855 standard. It's something that can be used as supplemental and provide an additional layer of protection to your systems. So with that, I'm going to turn it back over to Sonora, and we'll look through some of the questions.
Thank you so much for the great information. I just want to remind everyone that if you would like to submit questions in these last few minutes, you can do so in the chat box on the left side of your screen. I have a few questions that have already come in here. First, do the IFC updates, specifically IFC 2018, do they automatically take effect in the 42 states that have adopted IFC? Or do legislators have to adopt a specific version? I think, Chuck, that might be one for you.
Yes, they don't automatically. They have to be adopted. Generally, they're adopted as part of a package of building codes on a regular cycle, 3-year or 5-year cycle, and so the answer is no, they're not automatic. They have to be adopted. And I'll give you for instance, California is one of the states that has adopted the IFC, but like many states, it took the IFC that was published and modified it in some fairly minor ways. And so they approved it back in last fall, and the California version of IFC 2018 becomes effective July 1 this year. So,
great, thank you, Chuck. Laurie, I think this one is for you. Can you confirm, is UL 9540A the only acceptable large-scale fire testing procedure?
That is the one that is being referenced in the code, but I think, I suppose if you had done some other version of that testing, large-scale fire testing, I guess you could go to the AHJ and ask them if they will accept it. I guess it's maybe a little easier to go with one that has been, actually identified in the code as an acceptable method, but I don't think it's maybe the only one, but again, you'd have to seek approval from the AHJ. They have the final say. Even with 9540A, even with the reference to that, they still have in that the AHJ has to approve it. So, you know, when we do the 9540A, there's a report that we provide, and, you know, the client would have to present that to the AHJ, and they would still have to review and approve it even with that. So they always have that as the option. So that might be a way to maybe try to get maybe another method, but, you know, that's always tends to be a little more difficult, but not impossible.
Sonora, this is Chuck. If I can just add one thing to that. As Laurie just mentioned, there are equivalency provisions in both 855 and the IFC, which allow people to propose if they for some reason they think 9540A doesn't fit, they can propose their own. But it has to be, as Laurie said, it has to be approved by the AHJ.
Perfect. Thank you. I think, Chuck, this question's in reference to the building size that you covered before. Someone wants to know, how would a 300 megawatt indoor facility work? Would you have to separate it into 600 kilowatt sections? Because there's a feeling that would be enormous and economical. So if you can comment a little bit on how a larger indoor facility would work under the new code.
Right. So a 300 megawatt hour facility, if you wanted to get by without doing additional hazard mitigation analyses and large-scale fire testing, you would be limited to 600 kilowatt hour areas, fire areas, and that's pretty ridiculous to have 300 megawatt divided by 600 kilowatt would be an awful lot of spaces. That said, the utility exclusion under the IFC might cover that. If it turned out that it was being done in conjunction with the utility, under the auspices of the utility, something that large sounds like a grid scale rather than a local application.
Thank you. Another question here. Does the utility exclusion apply to ISO RTO projects?
Well, these codes are being, the answer is probably. These codes are relatively new, so they haven't had the benefit of going through a number of code cycles like NFPA Std, the National Electrical Code, and some of the other codes. And so some of this language, most of this language has never been tested, but it would be my take on it that if it was an ISO RTO project, that in fact it would be subject to the exclusion. And in the IFC only, right now 855 doesn't have it.
Thank you. I'll take a couple more questions before we have to close out because we have some really good ones in here. Is there a requirement for an energy storage container to have outdoor signaling horns or strobes? I think, Chuck, that one is for you.
Well, I'm going to hedge kind of like I did on the last one and say possibly. The outdoor exclusion, in fact, the indoor and outdoor installations requirements are essentially the same unless you have an outdoor installation that's more than 100 feet from certain exposures, storage, a bunch of exposures that are listed. So if it was more than 100 feet away, 100 feet or more away, you could well be excluded. Closer, it's going to be if you're closer than 100 feet, it'd be my opinion that you're probably going to be subject to it, though you can petition your AHJ for relief in various outdoor applications. So, again, it's kind of it's untested language since it's so new, but my opinion would be 100 feet, you don't need them. Less than 100 feet, you probably do.
Thank you. Another question here. Signaling and label has been mentioned a few times, and someone wants to know which standard or code should they refer to for more details on the labeling requirements for AC and DC electric disconnects for energy storage systems.
This is Chuck. Can I volunteer Steve to answer that?
Sure, Steve.
Or Laurie.
Or Laurie.
I would defer to Laurie on that. I'm not sure.
Well, we have like output requirements in the nameplate for the energy storage system, and that would be, as far as the outputs, that would be kind of the output current. And I have to look up all the details, but output current and voltage and what the output power is. Short circuit, we have a short circuit rating of God. I should look at that. I should know that off the top of my head. But there's a number of different things that we require as far as output, as well as input. What sort of input goes into the energy storage system. Again, the same sort of things that you'd be concerned of as far as voltage, and also phases and if it's more than one phase going out, and or whether it's AC or DC and things like that, so they kind of understand what is the level of power, voltage, etc., coming out of that system. So I can look it up in the standard and provide that, but pretty much what you would expect, so that you know what can connect to it. And also what we do have too on these systems as part of our certification marking is to require what sort of utility interaction it has, whether it's utility interactive or grid support utility interactive, based on how it's evaluated, whether it's to the IEEE 1547 standards for utility interactive or that special supplement that was put into 1741. So we have that as well, so that as far as it's grid interaction, what that's, so it matches with what the inverter converter is intended to do. So all of that stuff. So I can provide, I don't know if you provide information afterwards. I can send that into Sonora to answer some of these afterwards. I don't know. But that's kind of an idea of what we require on the nameplate of energy storage systems, including weight and things like that. That becomes important for indoor installations, footprint, stuff like that.
Great. Thank you, Laurie. We're about 3 minutes past the hour, but I have one final question that I will allow you to close out with, Laurie. So someone wants to know, is there a European standard that is equivalent to the UL 9540? And if not, are there plans to release one? Does anyone know?
Well, there are IEC standards under development. That's the IEC 62933 series. And the safety standards, there's a Part 5.1, which is sort of general safety, but it's only a technical specification. So it may or may not be adopted by the EU. They tend to oftentimes adopt, the IEC standards as their own. Right now we're working on a Part 5.2, which will be a standard, and that's for the battery energy storage system. So that's specific to that technology. The Part 1 is a specification, mostly talks about hazard analysis and FMEA, and it's got good information in it, but it's not what you would call normative language. Now there is one that was recently published by Germany. VDE is an organization that publishes safety. They do safety certification and standards development in Germany, and that's a VDE ARE 2510-50, kind of a long name, and that one is specifically for, and I think it's specifically lithium-ion battery systems for home use, and that's kind of like your small Tesla power walls and stuff, very specific application, and that's actually a German standard, that VDE standard, and that's probably pretty close to how we would evaluate a similar product under 9540. There's the 5.2 has some similarities, but it's still fairly general in my opinion, but it's under development. It's not done yet, so we'll have to see. It's just going, and it's on the CD stage, which is committee draft. So in Europe, once those get done, I think there might be a push because there's a lot of European representation on the committees to then turn those into EN standards, but I don't think that's happened yet.
Great, thank you. We have a lot of great questions still in the queue, but unfortunately we are 5 minutes over our time, so I will send the questions out to our speakers along with your contact information and for them to follow up with you to get those questions answered. I do thank everyone for all the engagement and the great questions, and I'd also like to thank our speakers, Steve Cummings, Laurie Florence, and Chuck Foster for the insightful and informative presentation, and thank everyone for attending today's webinar. If you have any questions about any of our upcoming events or webinars, or would like to submit an idea for a future webinar or conference, you can always email me at s.monks@energystorage.org. Thanks everyone and have a great day. Thank you, Steve, Laurie, and Chuck.
Welcome.